All right, so the equation that models the height of that fountain is given by negative 16t squared plus 89.6t. And it's asking you to find the vertex of this graph. Okay, so again, there's a couple different ways to find the vertex. One, you could enter this in your Y editor and look at the graph of it. However, that will take you some time to maneuver the viewing window. What I would recommend is go ahead and use the method if it's given in standard form. Okay? Or actually, I'll show you all three methods. So the first method, you could graph it. Okay? Again, I'd say that's the least helpful way. It takes the most time to do. So that's the fact that it's given as standard form, or I'm sorry, oops, just given the graph or given the equation using your TI-89. Okay, I would recommend you don't do that. There's two other ways that you can approach this that are probably easier. Since all you need to do is find the vertex, what we can do is we can use negative b over 2a to find the vertex. Okay, because this is written in standard form, I would probably use this method. It's probably, in my opinion, probably the easiest way to do it. And so, yes?
Is there a way we can have vertex as one of the things?
If you define it in that form. If you want, like when I have time in class, just call me over and I'll show you. All right, so if you want to find the vertex here, what you can do is you take negative b, so negative 89.6 over 2 times the a, which is negative 16. The negatives cancel, and so I can calculate this through 89.6 divided by 32. So that's going to give me 2.8. Okay, so that is the x-coordinate of my vertex. Okay, to find the y-coordinate, I'm simply going to plug this in for my t's in this original function. So if I took negative 16 t squared plus 89.6 t, I'll use my with key when t is equal to 2.8. I can just highlight this, even if it happened to be something that wasn't a terminating decimal. I could just highlight it and bring it down and hit enter, and this is going to give me my 125.44, the y-coordinate of my vertex. So this is my answer. If it's asking you what does the information mean, this means the amount of time it takes to reach that maximum height. Okay, and this tells you what that maximum height is. Right, so that's the method I would probably choose. Now, there's another method that you can use, right? Because this form, just the way that this form happens to be, since it's in standard form, I would use this method. But you can also write it as an intercept form pretty easily because there's no y-intercept here. So if you were to factor out a t from this, so you get t, or you get h is equal to t times the quantity negative 16t plus 89.6. What you could do is if you found both of these are now intercepts. So I changed this into intercept form, and I found these two intercepts. So I get an intercept of 0, and I get an intercept where this factor is equal to 0. So if I were to try to find where is this equal to 0, I can use the solve feature, negative 16t plus 89.6, set that equal to 0 and solve for t. So I get 5.6. So these are my two x-intercepts. And so if you recall, again, this isn't a set of coordinates, so I'll put an and here. These are just my two x-intercepts. So the x-coordinate of our vertex is going to be the average of those. So if I just take 0 plus 5.6, and I take the average, divide that by 2, I get 2.8, and then again plug it in, you'd get the same value. Plug it back into either this form or the original form, and you can find what that corresponding y would be. So those are the three different ways that we have, right, to find our vertex. Graph it, use the negative b over 2a to find the x-coordinate of the vertex and then plug that in, or use the intercepts, x-intercepts, find the average of those. Halfway between the x-intercepts is going to be the x-coordinate of your vertex.